All right, so these notes are about negative numbers. It's going to basically review and recap what we've been doing in the Big Ideas program. So negative numbers are numbers that are less than 0 are called negative numbers. If you recall, we talked about that you have to have a negative sign in front of negative numbers, although in accounting sometimes they use red ink to indicate that something's negative or something that the business has to pay out, as opposed to black numbers they use for money coming into the company. That's the idea of Black Friday. As opposed to positive numbers, you don't have to have a symbol in front. You can, but you don't have to. It's implied that it's going to be a positive number if there's no symbol in front. So we did a lot with number lines, and if you recall, as the numbers go to the right, they're getting bigger. And as you look at numbers going to the left, or if it's a vertical number line going down, that means the numbers are getting smaller. So two numbers are opposites. So opposites was one of the terms that we had. If on the number line they are the same distance from 0 but on opposite sides of 0. So for example, 5 and -5 are opposites of each other. If you're asked to give the opposite of something, you're never going to say they're equal. So you would say, we have a notation here. So you can put a negative sign in front of a number to indicate that we're looking for its opposite. So the example here has the negative of -25 means I want to find the opposite of -25, and therefore I would have 25 be the result. For the next part, we're going to talk about absolute value. That was the most recent part, only because we might use that term when describing how to compare fractions, positive, negative numbers with or without fractions. So I'm actually going to clear the ink and scroll it down, because there'll be some practice problems that go along with that. The absolute value of a number is its distance from 0 on a number line. So therefore it's always going to be a positive number or it's going to be 0. When I'm talking about distance, I'm always talking about a positive amount, as opposed to when we have these relational things like how much did it change. That's not quite a distance. That might be saying it changed going up versus it changed going down. So when we're talking about absolute value, we're talking about the distance, so it's always positive or 0 if we're talking about 0 itself. And we specify the absolute value of a number by writing it in between two vertical bars. So I'm going to go ahead and pause the recording for a moment so you can fill in these 5 examples, and then we'll have them filled in when we resume recording. So what you should have found was that the absolute value of -7 is 7. The absolute value of 0 is 0. The absolute value of positive 9.9 is 9.9. And any of these non-zero values can have a positive sign in front of the absolute value as well. The absolute value of 7 is 7. The absolute value of -2.7 is 2.7. Another term that we had was integers. Now, negative numbers in general could have fractions, could have decimals, but integers cannot. So integers are the whole numbers and their opposites. So it's a little bit different. It's the whole numbers as well as the opposites of the whole numbers. So we could have rational numbers as well. When I'm talking about integers, I'm talking about not without fractions, without decimals, but rational numbers can be positive or can be negative. I'm actually going to have to clear it and scroll it back up, because we're going to need to see that number line from the top. Oh, that squeezes it in. So rational numbers with fractions or decimals. Oops. Thought the word parts was going to be there. So rational numbers with decimal or fraction parts. Can also be negative. So we might be asked to plot -2.5 or -5.25 on the number line. So that's why I scrolled it back so we can see that number line again. So -2.5, similar to its mirror image, its opposite, 2.5 has to fall between the -2 and the -3, just like 2.5 would fall between -2 and -3, and it's exactly halfway between. So we look and we find our -2, we find our -3, and halfway between is where we'd plot and label -2.5. Similarly, -5.25, I can think about how I would plot 5.25 on the number line. It would be 1/4 of the way past 5 towards 6. So for -5.25, I'm going to go 1/4 of the way, approximately, past -5 towards -6, -5.25. So we should feel comfortable plotting any type of positive or negative number on the number line. Then we're going to go into comparing and ordering. We did a lot of that in the first few sections of chapter 6. So compare the following numbers. I'm going to have you pause the video so you can fill in these 8, and then we'll go over the answers. So all of those examples were integers, so they're a little bit easier to compare. If they're fractions and decimals, you have a little bit more in order to analyze which one has the bigger absolute value, essentially, to figure out if something's more negative or more positive. Or if one's negative and one's positive, you don't even have to look at the actual numbers. So check over your answers for that. And to sum that up, what we end up finding is that any positive number is always greater than a negative number. But to think about which negative number is bigger, we don't even talk about positives, you've been comparing those for years. If you have two positive numbers, you know, the bigger number is bigger. But if you have two negative numbers, and you think about which negative number is bigger, you can think of which is closer to 0. It's going to be the closest to being out of debt or to the 0 or positive side. In general, if you look at the numerical part or the absolute value, its absolute value will be smaller in order for that negative number to be bigger. It's less negative than the other number. So if we're going to put numbers in order, we would have to look and find our negative numbers, and there's going to go first if we're doing least to greatest. So you look at your negative numbers and you find how much is the most negative of those. So we have -4. And then the next one, and again, I like to cross things off so I don't accidentally include them again. And I know that now I only have to analyze these handful of numbers that are left. Each time I have fewer and fewer I have to consider. And when I'm making my list, I have to make sure I put things back in the format that they were in originally. One thing we should add to this is having an absolute value. We saw that as well. We could have some in our list that have absolute values, that we have to take that extra step to consider. But that's the quick summary of what we've been doing with positive negative numbers.